Hello, and welcome to this wonderful webinar with Jessica Talisman. Jessica Talisman is very, very special. She has been a proponent of information architecture, taxonomy, ontology, knowledge graphs, just a number of interdisciplinary areas. But she's been just a force of nature, and I'm really happy to have her be a keynote presentation for us today. She's going to be presenting intentional arrangement, artificial intelligence, and information architecture. And with that, I'll pass the mic over to you, Jessica.
Thank you. I'm excited to be here and part of this community. Joaquin's building a pretty miraculous and amazing, vibrant community, so thank you. Um, so I'm an information scientist, just a little bit about me, and I've worked within the field of technology for, I don't know, 25 years. I currently work at Amazon. Um, I have worked as an academic librarian and worked wrangling data in some form or fashion with e-commerce, government systems, ed tech, ad tech operations, and GLAM, which is galleries, libraries, art, and museums. I have a background, I have a master's in teaching, and also I have a master's in information and library science. I currently work for Amazon, but do have an exciting change, so stay tuned next week for that. Um, so let's get into it. Uh, one of my most favorite academics in this area of discipline of organizing, he wrote an amazing book. His name's Robert Glushko. Um, his idea of intentional arrangement, and I would think that he coined the phrase, is it emphasizes explicit or implicit acts of organization by people or by computational processes acting as proxies for or as implementations of human intentionality. And I think this is very important because LLMs or AI are affecting every domain and industry with one universal truth that binds them all. Initiating and deploying LLMs requires well-defined structured data. That's our common DNA. To boot, LLMs also benefit from data that is clear and curated to narrow the scope to represent really what is the digital fingerprint of a domain or an organization. So the cleaning and curation and structuring of data is not for the faint of heart, as many of us have discovered. Some of us are kicking at the door, hoping for an AI miracle where we can appropriate the tasks of building taxonomies and ontologies, basically our information architecture, to LLMs, and to automate that like we want to automate everything with AI. Intentional arrangement does require a human in the loop to set this intention to choose how to represent and present ourselves to AI. To be intentional is like various other mental states. It consists of two main components, a content and an attitude towards this content. The content of an intention is the action plan and the attitude, which involves a commitment to execute the action. So if our action is to deploy LLMs, we need to be intentional about our content. Intentions may share the same content with other mental states like belief or desires, which I think constitute or are part of this equation. But the different mental states are distinguished from each other with attitudes and commitment to intentional arrangement. So when we look at the foundation of data or information on the web, we look at uh, really what or how we can intentionally arrange our environments and define our environments. So when we look at this, we can look at the history of digital libraries, the transformation from physical to digital. In cataloging web and digital resources, librarians have been focused on structuring data to present the aboutness of a digital object and the relationship between those objects. So before we really saw this proliferation of semantic technologies, metadata was used to generate structured indexes to support keyword retrieval, where knowledge was implicit in structured textual information. So early digital libraries digitized the structure of card catalog systems, bringing the macroscopic and microscopic into view. So it was the very digitization of library systems that served as the foundation of structured information on the web. When we look at aboutness and cognitive modeling, which is part of this intentional arrangement, a core principle in semantic systems and the underpinnings of AI involve cognitive modeling. So, what is cognitive modeling? And how do cognitive models affect AI? So, cognitive models of information retrieval rests on the mix of areas such as cognitive science, human computer interaction, information retrieval, and library science. Cognitive models describe the relationships between a person's cognitive model, which we often refer to as a mental model, and um, the information sought and the very organization of that information. So, cognitive architecture then is about the structural properties of a modeling system. So, cognitive modeling constrains a system to live within the boundaries of the cognitive architecture and also informs the system and humans of the limitations, gaps, and shortcomings of a system. We can think of weather forecasting models, Earth simulator models, flight simulator models, molecular protein folding models, and neural network models as examples of cognitive modeling and cognitive architecture. So a cognitive model structures the aboutness of information. A cognitive model is founded upon the human and machine cognitive models. They really can't be separated from one another. And this bridges the gap to make information accessible. So these exact techniques of cognitive modeling have been an essential part of the formation of the World Wide Web and the technology landscape of today. Think of the HTTP and HTML protocols, which underlie the World Wide Web and took much of the inspiration of these concepts from information and library science to present documents which represent entities, linked data which connects those documents semantically, and a markup language which allows us to speak formally in machine readable structures for your documents. So some of the earliest big businesses built on the web also borrowed very heavily from well established information and library science techniques. So it did not live in isolation. Yahoo can be thought of as an early online card catalog system, rendering as an index which organized the web content into hierarchies with ontological cross references. Google built a massive search empire on top of the concept of using the number of cross references to a page as an indicator of that page's reputation and relevancy. Counts of scholarly citations were used as a marker of relevance in library science long before the web ever came about. So these principles are fundamental. In 1994, two Stanford students started Yahoo, a manually constructed table of contents for websites. Other early search engines emerged, such as Lycos and WebCrawler, and began automatically indexing web pages, focusing on keyword-based techniques to rank search results. Around the same time, Google's Larry Page and Sergey Brin, funded under the National Science Foundation supported Digital Library Initiative project at Stanford, took an interest in the web as a collection. They built upon the Yahoo indexing work to invent web page ranking. Page ranking assumes the value of linking documents or pages on the web. Linked data provides a map to the sharing of information, grounding digital objects in a source of truth based on human classification of knowledge. Classification of knowledge, in this case, is the human created links between web pages. This is an intentional arrangement. The original Google prototype crawled from pages to page by following links. It compiled a standard text index and mapped out a vast family tree that reflected the web links among pages. It was like an early knowledge graph. To calculate rankings from the family tree or taxonomy, Sergey and Larry developed the page rank method. Page rank is the methodology of applying ranks to web pages. A page ranks highly if many other highly ranked web pages link to it. Those other pages' rankings, in turn, depend on the pages that linked to them. There was a desire here. And there was intention. There were beliefs, but the intentional arrangement of page ranking is the very definition of how we organize our data today. So let's look at how this space has evolved in recent years, because technology is really an assemblance or building upon former discoveries or successes within a space. So today, the largest innovation in search engines and information retrieval on the web have been around generative AI techniques or large language models. LLMs are built using an intelligence technique called deep learning, which employs multi-layered neural networks with layers of transformers. OpenAI's ChatGPT is the most well-known of these LLMs today. So the GPT stands for Generative Pre-trained Transformer, and these models can be absolutely massive. The training data sets for the ChatGPT model are over 45 terabytes in size, and training models have over 1.5 billion parameters, which you can think of as individual logic gates within the model. As you can imagine, given these numbers, these models are quite expensive to train in terms of compute power, money, and time. Costs for a single training run can top $100 million. Because of the huge cost to train an LLM, AI and ML researchers working in the space have developed a technique called retrieval augmented generation, or RAG for short. I'm sure many of you have heard this term or worked with it. RAG is a technique that allows you to supplement the data in the pre-trained model with other context data, which wasn't available when the foundational LLM was trained. A good example of when this comes in handy is when you want to join your internal company's data sources like wikis or help pages and internal knowledge graphs with the power of the LLM. Paying OpenAI for a custom trained model that includes the 45 terabytes of their standard data sources, as well as your corporate data assets, would be prohibitively expensive in most cases. With RAG, you can inject the additional context at model prompting time. However, not all RAG results will be the same. The structure, the quality, and consistency of the input can have a huge impact on your results. It's basically the garbage in, garbage out problem. In order to get the best results from LLMs and RAGs, you need to have high quality and well curated data, ideally in the form of a knowledge graph. This can be seen as a type of intentional arrangement post haste. So now we get into AI and embodied cognition, which is usually attributed to humans and their relationships to physical environments and sensory feedback. Embodied cognition is actually a subdomain of cognitive modeling and open dynamical systems. So the idea of embodied cognition is shaped by the indicators and mediators within a system. The indicators carry information, and the existence of an object is an information environment. How does this work in a machine-based system? So think of smells, tastes, physical pain, all feedback loops for humans. But for machines and AI, we'll take the example of taxonomy. So the hierarchy of taxonomy is an indicator or serves up indicators that these information bits exist relative to other pieces of information. The mediator delivers information about the environment that the information lives in. Think of a mediator as a description of the environment, including language, translations, and agents with it. So a mediator may be described using a schema, an ontology, or a knowledge graph. So RAG is a great example of a mediator in a dynamic system like AI. Simplified, these information objects exist as artifacts first and are assigned descriptions. The descriptions are modeled for the human cognitive model and the machine cognitive model. The goal is to make use of information acquired during the information gathering process and present the information in an organized and accurate fashion. This is not leaving it to the AI gods to declare an oracle or rendition of intended output, but setting the intention before the output arrives. Information retrieval is our end goal. Coined in 1952 as a facet of library science, information retrieval advances in libraries were beginning to expand into the digital realm very early, so around 1952, and that is beyond managing physical repositories of books. We were moving into digital already. Vast improvements in cataloging and indexing presented new models to support human information retrieval processes in digital landscapes. Where does information architecture fit in? Information architecture is about describing aboutness. It is intentional arrangement to create descriptive arrangement, or what we may call semantic arrangement. We are experts in prioritizing the structure and meaning of objects or describing artifacts, facts within a system. We create systems for organizing based upon methodologies used for thousands of years in the library science domain. Classification schemes such as taxonomies and ontologies are used to describe things, including context and relationship between artifacts. And the co-location of these things is critical to understand beyond the local instance. We're always concerned about how the local affects the global. We want to make information accessible to all, including machines. If you look at the aboutness of an information artifact in the library domain, we can see each part that makes up the whole. We have a call number, we have location, author, title, subtitle, and so on. These are descriptions of instances of that artifact, in this case, a book. We know that this artifact is a who, what, when, where, why, and how. But the why is left up to the user, which happens at the point in which the information is retrieved. It is up to the end user to determine the value of information and to integrate the information to then convert it into knowledge. So the age-old question of when does information become knowledge? This is intentional to leave the user or the end user to decide upon the why. Why is that information important and how can it be synthesized to become knowledge? So to imbue knowledge, data must be structured to become information. So the progression of from termless to ontology. Controlled vocabularies, taxonomies, thesaurus, and ontologies represent stages or layers in structured data and ways to deal with that complexity. So the sequence was codified as a methodology with the digitization of bibliographic records in the library space and linking of these records in the web space. This method proved successful and aimed to support information retrieval and cognitive models to support human information retrieval and machine information retrieval. If machines and humans are able to discover and manage information successfully, then the data modeling methodology works. So to be clear, we're not tasked with interpreting data or information, so that would introduce bias. I mean, with the transition from information to knowledge. We only want to structure artifacts to help humans and machines find the things as accurately and quickly as possible. So this modeling practice is intentional arrangement. The only way artifacts can act upon the relationships stated in this intentional relationship is with intentional data interoperability. Data interoperability relies upon the structure of files, metadata models, and metadata standards, common vocabularies, and a standard lexicon. Without this trifecta, interoperability is difficult, if not impossible. Consistency is key for both machines and people. If a machine cannot parse and understand the aboutness of an object, then the information is lost. Structured data supports this interoperability. Data interoperability is fundamental to information retrieval and processing. The large worldwide network of bibliographic records, for example, is connective tissue. It is the very essence of recorded knowledge and the basis for understanding the distribution of recorded digital collections for the benefits of learning, research, and information-seeking behaviors. So there's several sources that are pretty common tools that all roll up and are presented in machine readable format. And this is an example a bibliographic record, but also an authority source. An authority source basically works in the real world to help to control or ground a digital object and establish its existence. This could be a book, a movie, a song, an article, or an image. Part of authority control is to minimize the opportunity for misinformation. Authority control is used in ontologies to codify the meaning of things relative to other things in a vast sea of information. An ontology declares a book as a book and then extrapolates to define that the book is a paperback in a nonfiction work. In this vein, it is not unlike the data in your organization. So we don't perceive of duplicate objects until we look for or discover them. It may not seem like a big deal to present a machine or people with individual data objects that are pretty much the same. But compound these occurrences in a system and you arrive at a findability problem. Why try to find more information in the existing landscape if we can't make sense of the data within? You should not think of your data as isolated in your organization. You should think of it as connected to the broader corpus of structured information or data in the world. Grounding concepts in truth and linked data to authority sources also helps to define said concepts. This is done usually using a URI or URN to create permalinks to these authority sources to help to invoke authority control. They're foundational to robust knowledge graphs. So now we move into a real world example of how this works in practice. And so we are going to use Cookie Monster, beloved Cookie Monster, as an example. Cookie could mean many things, especially in the technology sphere. And so understanding how authority sources and authority control works and how we can help to structure information to invoke an intentional arrangement. Authority records are contained within authority sources and can have authority files. So linked data is structured information contained in a database or data set that follows resource description framework or RDF. So that's really important. It's a foundation for knowledge graphs. And it's a standard model for sharing data on the web and also the de facto standard for linked data. So put more simply, RDF is a structured way to represent information about resources. Here's an example. To us, it might be obvious that Cookie Monster's favorite food is a small, round, baked good. However, cookies can also refer to the blocks of data that are created when browsing a website. Since you do not want the computer to think that Cookie Monster likes eating blocks of data, you need to uniquely identify each entity. This is where the Uniform Resource Identifier, or URI, comes in. A unique persistent string that consistently represents a distinct person, place, or thing, or a piece of information. By using a URI to refer to the same entity in multiple triples and multiple data sets, clusters of data can then be connected to one another. Computers are the ultimate literalists. Words are strings, but the same string can have different meanings. Where the URI is the authority source, the authority file is the object that describes the actual thing. So we're looking at Cookie Monster. If you link to the Library of Congress Authority File Service, you will find the URI, which for machines handles variants to resolve entities and define Cookie Monster more explicitly. This is a much more efficient way to communicate with machines. We now know that Cookie Monster is a fictitious character. He also goes by Alistar Cookie, and the Wikidata record is closely related, but not an exact match. Another authority file with an HTTP endpoint to describe Cookie Monster. This is the basis for knowledge graphs and libraries. It's the same principles, same layering of structures, same prioritization of machines and human cognition, presenting these things in a structured way so that there's not confusion as to who is Cookie Monster, with the understanding of Cookie Monster's place in the world by way of relationships to other things in the universe. Wikidata brings library classification of digital objects into the Internet Commons. The systems are interoperable. All too often, I do work with engineers excited about linked data and knowledge graphs. These people are very quick to jump on using Wikipedia as a source of truth for lack of an ontology. However, Wikipedia is not the source file or authority source. Wikidata is the authority source for Wikipedia, and information quality governance with checks and balances, most importantly, tons of authority files within. If present day AI is about discovery of information, structured data is instrumental. Training data, such as using Wikidata and Wikipedia, are also important as inputs to AI because of structured data. These taxonomies and ontologies shape how large language models assemble information to allow for meaningful input. Wikidata represents intentional arrangement. So I ask, is this a coincidence that ChatGPT output can contain Wikidata ontology identifiers? I personally don't think so. Through my research, studies, and work, ChatGPT is trained on Wikidata and other linked authority sources. That is well known. ChatGPT relies upon authority control to consume packages of information effectively and efficiently. ChatGPT is great for generating Sparkle queries to search knowledge graphs. Just a little tip. A great utility to leverage if you want to explore how data is structured in graphs, such as Wikidata, Babel, and DBpedia. Within an authority source, as we reviewed earlier, there are authority files. The hyperlinked terms in the gray sidebar is an ontological property, part of Wikidata's larger taxonomy and ontology. And Wikidata is a knowledge graph because Wikidata has structured data. Why? It works and it's inherently scalable and extensible. On a Wikidata page, you can follow the sequence, and Wikidata does have available downloads of the ontology with short definitions. Notice how nicely Wikidata captures Cookie Monster, referencing the catchphrases, me want cookie, me like cookie. The definition of Cookie Monster is created by an LLM because of the context of its associations, including the tagline, me want cookie. The authority records and linked data can be found in the surfacing of descriptions intentionally arranged in these open source knowledge graphs. The core of how we structure and define digital objects is really brought to life here. If a machine consumes authority files and follows an explicit roadmap defined by ontologies and linked data, the convergence and assemblance of this information renders as a complete descriptive explanation for Cookie Monster. We should be quite curious as to what ChatGPT outputs would look like if we were to remove structured data sources like Wikidata, Library of Congress, and other highly structured open data sources from the training data sets for that model. The web of data is evident as descriptions and relations give way to descriptive context. If we look at how Mistral, for example, defines Cookie Monster as opposed to ChatGPT, we can find a very descriptive answer to who is Cookie Monster. It's interesting to see the depth of different models, boundaries, and clear intention in the structuring and formal output. Llama is short and succinct, and obviously changing the inference configurations can definitely change the depth of the answer, but we kept things pretty consistent throughout all of these. If we look at Cohere, you can see it's very descriptive and very detailed, and is able to draw from those linked data records or authority sources or authority files to be able to give us more depth. And I think this can be attributed to some of the configurations. If we look at Anthropic's Claude, it delivers a very organized, formatted response. Again, an intentional and consistent presentation from Anthropic. And again, if we look at A121 Labs, we can see that it's a little bit more succinct again. It focuses mostly on Cookie Monster's love of cookies. So how do these models train? I would propose just an idea of there being intention or intentional arrangement at the base of the training data. So here's where to start to explore structured data, authority sources, taxonomies, and ontologies. It's a collection of authority sources, but it's not exhaustive. So these are just some of the structured data sources that also happen to have knowledge graphs that are open. There are many more than what's presented on this page. All of these authority sources, however, on this page link to one another, and some govern others. They reconcile duplicates. They help to collapse pages. Imagine the scale of this linked data web. Now imagine if your training data was structured and linked to these authority sources as HTTP permalinks. Your LLM would not be wandering the hallways looking for context and meaning. The taxonomies and ontologies you build as part of your information architecture, structured as knowledge graphs, can match the intention of AI to shape data statistically and programmatically into information and output. Delivered to the user or organization with intention, given the right classification structure or hierarchy to follow, much like we would create a roadmap. So can we get by with unstructured data? The first thought is data quality. We all know that data quality is an issue with training data and in implementing and deploying models. If you use training data and curation, if you set intention, if you care about how your model presents your data, if you care about costs, you care about efficiency, and most of all, you care about interoperability, you're going to look at structured linked data. You're going to look at your data quality. Data quality is the underpinning. It's really the benefit of structuring data because it's part of the process. Structured data includes the aboutness of entities, objects, artifacts, and it defines things. Structured linked data with cognitive models designed for information retrieval tasks has the added benefit of reconciling and cleaning data as we move through the process. When we look at aboutness, intentional arrangement, and AI, and the larger scope of information architecture, we understand that words can be hard. This is a language model, and I think sometimes we lose sight of the fact that we're working with large language models. Words do have meaning, and without language, we don't have language models. Can we take these global concepts, such as cognitive modeling, aboutness, and intentional arrangement, and really help models train, and as a result, deliver more relevant and accurate output? Yes, I mean, it's the foundation of how these models work. The very act of structuring your data for human and machine consumption is an intentional arrangement. Understanding the LLM's need for aboutness and intentional arrangement of things is clear. Context and structure is needed to derive meaning, and we desire to extract meaning from AI. When we look at this in general, you know, the father, if we want to call him that, Aristotle, um, in his categories, this is 384 to 322 BC, identified 10 possible kinds of things that may be the subject or the predicate of a proposition. So if we think of ontology in the realm of defining things within our space, Aristotle defined 4 different ontological dimensions by which human cognition operates in his Metaphysics Theta book. Ontological dimensions exist to represent intentional arrangement of cognition, actions, choice, and goals, essentially cognitive embodiment. According to the various, so these are very, very important, is that there's those 4 aspects to ontological dimensions defined by Aristotle. According to the various categories or ways of addressing of being as such, according to its truth or falsity, whether it exists in and of itself or simply, according to its potency, movement, or finished presence. Most of all, with information architecture, it's important to be a participant, not simply a receiver of AI output. Building for AI successfully requires intentional arrangement to meet our goals and declare actions. Information architecture is a form of intentional arrangement with a human in the loop. And by doing so, we can be proactive and interact with AI to help to curate or mediate the system to derive the meaning that we want and the results we want and output we want. We shape the world we want to embody. So thank you. I appreciate the opportunity to present and interested in further discussions about the idea of intentional arrangement and AI.
Thank you for your presentation, Jessica. As Jessica has mentioned, we're open for discussion. If you'd like to leave your questions, comments, concerns, anything you'd like, you could put it in the comments and we'll respond to it in order of in order of engagement. Um, as far as I can tell, Jessica, you always bring a very broad context and then you layer these ideas in order of importance from this is the broader context to this is the more relevant perspectives of this sort of discipline. And I really appreciate you taking us through the entire value chain. I think it's very important to paint that picture. We are people and we contextualize our world. And the only way we can share meaning between our worlds is using language. Now, that could be written, that could be verbal, it could be symbols. But at the end of the day, we need to have some sort of social contract to talk about me likey cookies, Cookie Monster. Otherwise, it's going to be an open door for confusion or misrepresentation of an entity.
Mhm.
Um, and I really enjoy hearing you talk and present these ideas because you are the type of person that teaches the teacher. You try to bring these ideas so other practitioners can take the broader context into perspective and walk away from a tool centric approach when engaging these social technical problems and engage more from the educational social perspective because these are all people problems. Most of these things are people problems. The people that create the tools, people that use the tools are people.
And the output, I think what's really interesting is this is this is part of the general life cycle. AI in context, it's built upon everything that we have accomplished so far in the world of information retrieval, and the idea of finding, searching for what we're looking for and engaging. Um, and it's interesting to me that this is a task that we are disembodied from, or can be a task. The idea of arranging or intentionally cleaning and structuring our data, that it would be in our best interest to be able to mostly also take control of the results and the output that we want to see. That it's for the long haul and not for the short, quick wins.
Can you talk a little bit more about that? I mean, I think it's an important concept to discuss.
Hmm.
That from your the label that you choose to use professionally, information architect, you create something that is for the long haul.
Hmm.
What do you mean by that?
Is that aside from AI, there's going to be other discoveries, other utilities that are going to present themselves as we progress. I mean, we talk about, where AI is going to go from here, for example. And so the idea of being able to present your information in a way that's customized, like I like to say, that digital fingerprint. Um, Being able to leverage something that is curated, personalized to the organization or domain space will render or garner um, better results. So I think that the application of AI, for example, as an information retrieval device or utility has its value. However, when you search simply with a chatbot, it's going to return an answer, or it might give you an semblance of answers if you've ever been or used a chatbot where it gives you options that are derived from some controlled list of things you might be looking for within like a document library. And in fact, the act of searching for information has always been that you're given a choice as a human based off of several results that present themselves, like in a search engine. So we're changing the very way in which we retrieve information. And so it then puts the onus on us as humans to determine how that journey will unfold.
There's something that you said in a previous conversation we've had that has been rattling in my head for some time. And it was, if you want to learn how information really works and see a system that exemplifies this to a very high degree, look at how library systems work. Look at how libraries function,
Hmm.
because they have been the reservoir of information and information retrieval for a very long time. I mean, since the development of language and written language, right?
Hmm. And there's consistency, interoperability, and standardization behind that. So there are agreements in how we arrange things, how we present things. For example, you might see it in your own company or organization as like schema fields that are with required entries. That is a great step forward with intentional arrangement that everyone within an ETL system, for example, has to populate fields in order to publish data to a database. So that's something that's derived from information and library science. So libraries with card catalog systems or bibliographic records, the idea of linking documents is something that which we see in page ranking, for example, with Google. That has been in existence for thousands of years. So the idea of connecting things, creating context, relationship between things. There's different models, data modeling techniques that are used in information and library science, but essentially, it was called very early on informatics. And that idea of organizing things, resolving duplicates, resolving similes, for example, the way that we structure and present data to improve findability. This is going to sound very abstract. For any library and information science folks, there's a model called Ferber, which is used in cataloging quite a bit and how we organize information. Ferber's functional requirements of bibliographic records. The whole idea is that we represent a piece of work, so that you represent a thing. That original thing never goes away. So it might be Romeo and Juliet, the OG, the original Romeo and Juliet. Every derivative of that thing in any format is then also linked to the original entity. So Romeo and Juliet can have the movie, there might be a song, there might be a play, you have, the second edition, the third edition, paperback, hardcover. How do you distinguish all these things, but at the same time relate them and connect them, ground them in that truth? And that's something that I think, looking at some of these authority sources that I presented here, and looking at those base values, We all know that this has been fundamental to a lot of the training data um, that is used in AI. And so if we start to deconstruct the methodology, the presentation, the arrangement, we can start to make sense to that black box effect of how does it do that? There's a foundation there.
I think at some point we lost our way, and
Hmm.
there was a branch path of computer science is its own thing, and information science is its own thing. But in reality, it isn't. Computer science should build on top of information science. I mean, as you're saying, these are problems that have been solved and reused, and there's patterns that can be employed in any kind of use case. But if you look at a hospital, if you look at a telecommunications company, they might think to themselves, why do I care how a library works? Why do I care what Furby is?
Hmm. And
Little did they know.
it's
Yeah.
yeah, yeah, it's the idea is that like it's like any great work of art in my opinion is that copy the masters. There's nothing wrong with looking, and we all look at use cases all the time, but some of them can be very short term or relative to trends. So when we are able to build something that's pretty dynamic and extensible, that is built so that it can continue to expand, that we can scale our environment no matter the technology that's thrown at us, then we're able to bring intention towards goals. And that intention of understanding that the way that I structure this is going to affect the future, for example, of this company or organization or myself. And that being able to invest in that. And it's a personal investment as well. It's a work investment, it's a financial investment. That bringing that intention to how we arrange and present things it will pay off in the long haul, but it will also help to focus. Um, we all have to create, usually if you work at a larger company, you have to present your OKRs, objectives and key results. Can you create objectives and key results without intention? Sure. Does it benefit you or the organization? Maybe. Um, but the idea of being able to build upon the work you've done in the past, the ability to justify a pivot, to justify, uh, a certain investment from your company, it's really important to think about and look at how intentional arrangement and information architecture has played into the very foundation of the digital world that we live in today.
I think part of that has to do with the constraints. I think the only constraint that we experienced before the creation of computers was our creativity, our imagination. But once implementation details came into the picture, you only have this much file space to use. You only
Yep.
have these kind of computer programs or computer language to express yourself and develop these sort of frameworks of operating. I think that's when things started going downhill and fragmenting meaning. People weren't
Yeah.
able to use pure creativity to think through and solve these problems.
Right. And the idea, because I think what most of the intention that we as a general whole humans brought into this world, this new AI world, was the idea, leading first with automate,
Mm,
gonna automate everything. And that intention was good. Like it wasn't bad intention. It was the idea of lightening the load, saving money for companies, like whatever it may be. However, it was a little early, I think, for that type of automation for most organizations, because not all of us have the budgets of Amazon or Google or Microsoft and the talent necessarily to deploy things at scale. Plus, most of these companies, AI is not new. It's been around for a bit. And so, but it's new to all of us. So it's important, there is a creative aspect I think that people can seize here in helping to curate, organize, and present specifically the characteristics, nuances, context, relationships of your organization, what things mean, what's the context, what's the relationships between those things. And it can be actually quite fun um, to model that because you're able to get very specific um, and be very thoughtful about there's many creative ways you can deploy a really smart, intentionally arranged knowledge environment.
It's almost like going on an intellectual safari. You have to go and
Totally.
explore the domain and look at the giraffes and the lions, and
Yeah.
that's how the business works. And this actor talks to this other actor, and these are the work
Hmm.
products that are transported between organizational functions.
Hmm. And you're telling a story essentially. There's storytelling. You're drawing a picture. You're um, really declaring what is and what is not. We kind of lose sight of this, but a lot of cybersecurity models work off of sort of you see a lot actually being talked about right now with decision trees, for example, which is a basis or foundation in statistical models. So when we start to look at what is and what is not, and how we can creatively shape information or data in our organization to declare information to a model, it does become conversational even with the deployment. There's that aspect um, of driving from intent rather than driving from, I'm going to put my finger in the wind and see what happens.
Who should get in touch with you?
Anyone who's interested in discussing or talking further about it, I'd love to hear ideas, sharing of ideas. I think that's how we all grow. Um, and just to understand also just feedback. I'd love to hear what people's thoughts and sentiments are around this.
Well, I think you put a lovely presentation together, and you always blow me out of the water. I'm always learning new things from you. So I appreciate you accepting this presentation. And yeah, feel free to reach out to Jessica. She's awesome, always. And
Thanks.
tune in for the next presentation as well. We still have a couple for the remainder of the day. So
All right. Great. And please do not hesitate to get in touch. Okay.